Hi everyone, and welcome to the 20th event of PyBerlin. We're glad to have so many people online again for our fifth online event. So let me start with some great news. We have over 2,400 members. So thank you all for your interest in PyBerlin. So for those of you who are new, what's and why is PyBerlin? So PyBerlin is a very welcoming community based in Berlin who loves Python and loves sharing ideas. We are the organizers, and besides the good news, we also have some sad news. Unfortunately, one of our organizers, Miguel has decided to step back. And although as a new member of the team, I haven't met Miguel, I want to convey on behalf of the organizing team that we are very grateful for your time, Miguel. And we look forward to having you back soon. So be reminded to read and respect the code of conduct of PyBerlin and be nice. And also be reminded that it's always safe to ask questions, so don't hesitate. Today's agenda, we'll start with Ivana Kellyerova on avoiding becoming a 10x engineer, and then we'll have Mridu Bhatnagar with her talk about sets and frozen sets, and we are very glad and thankful to have our two speakers today. And also, there is a possibility, as always, to ask questions after each talk. For the first talk, the questions can be asked live on Slido, and here's the link and the event code. You also have these on the Meetup event description. Oh, sorry. It's the other way around. The first talk I will have questions answered offline, and the second one would be live. So the event code would be 20 and in 20-2. And you'll find the URL and the event description. And PyBerlin is looking for people that have something to share. So if you are interested in giving a talk or a lightning talk, please let us know, contact us, or submit your talk proposal at this URL. Also, as always, we are very thankful for every tweet about PyBerlin and for every follow on Twitter. Also, feel free to join the Python, the Berlin Python community Slack channel. And without further ado, I'd like to welcome our first speaker tonight, Ivana Kellyerova, with her talk on how to avoid becoming a 10x engineer.
Okay, hi everybody. Just let me share my screen. Okay. So thank you for the introduction. First of all, thanks for having me at PyBerlin. Um, and hello from Austria. So I'm here today to talk to you about engineering and balsamic sauce, and that's probably a sentence that you've never heard before, unless you were at my EuroPython talk. Um, so yeah, let's we will get to. Don't worry. But first, let's get some of the boilerplate out of the way. So, as I already said, my name is Ivana, and this is like a candid picture of me. This is what I usually look like when I'm coding. Since you can see the camera now, I thought it would be good to include an up-to-date picture. Um, yeah, so the important stuff. I like to paint mugs. I have way too many plants, and I sometimes speedrun. And if you don't know what speedrunning is, it's basically trying to complete a game as fast as possible or trying to complete some sort of goal in a game as fast as possible. It's a lot of fun. Can recommend watching and doing this as well. Um, so that's the important stuff. And like the less important stuff is that I am basically a web developer. I built aiohttp based APIs and web services at Wegfinder, which is an Austrian company, and I kind of like Python. It's okay. So um, I have been doing this programming thing for a while now. I basically started with some website stuff while at school, then worked for a bit in infosec, and then I moved basically back to web development. And sometime in between getting my first engineering job and bringing down my first production database, I came to realize that there are basically two things that I observed everywhere in the engineering circles. So the first thing is that everything sucks. Like whatever tool, software, library, process, you name it, there will be somebody who just doesn't like it and is very vocal about the fact that they in fact don't like it. Except Postgres, because Postgres is somehow this unicorn that seems to be like suspiciously well liked across the board for some reason. And the second thing that I observed is that everyone has opinions. Or like maybe it's not everyone, but it kind of feels like it, since the people with strong opinions tend to be very vocal about them, very loud. So there is this thing called the internet. You might have heard about it. It's an awesome place. Like, okay, maybe except for that. Um, yeah, just ignore it. Okay, okay. It has some minor hiccups, but like, what doesn't? Okay, how can you not like the place that brought us synonym roles? I mean, that's just not possible, right? Just ignore that. Trust me. Anyway, so there's a lot of stuff beyond your, let's call it, linguistic food endeavors that you can share on the internet. And there are many people doing just that. And the easiest thing to share on the internet is an opinion. And when it comes to opinions, the internet is basically like Dynamaxing them. People on the internet have opinions about all sorts of things. So, I mean, obviously, what it means to be a good or bad programmer or how to become one is no exception. And you have no doubt come across some of them already. Maybe you even sought them out. And many of them make a lot of sense, but others not that much. So, what I did for this talk is basically that I looked up what the internet has to say about being a good or bad programmer, so so that I can basically share this knowledge with you, and we can grow together as programmers and people in these roughly 25 minutes. So let's get right to it. So the first piece of advice that we will look at from the internet says that unless it's a real research or publication conference where people discuss and propose solutions to challenging problems, you won't find top notch programmers in these meetups. Why? Because more often than not, these meetups tend to waste too much time rather than actually solving some problem. So this is awkward. I mean, I guess we can just, all go home because we're just really mediocre since we're at a meetup, right? I mean, I do like going to conferences and meetups and, see what other people are doing and see what other technologies are out there, solutions, that sort of thing. But I guess that somehow correlates with me being mediocre according to somebody on the internet, so it's too bad. Um, I hope you'll excuse me if I just skip this part where I try to debunk this because, considering the circumstances, I think that's not necessary. So, another thing, or another sign of a good programmer that you can find on the internet is that they glance over your shoulder and point at the bug in your code with their finger. Okay, please don't do that, like, unless specifically asked, because I mean, you might be able to demonstrate your superior bug finding skills, but it'll probably not win you many friends. So, coming up, you can often see hallmarks of great bad programmers by phrases such as, I am so sad that my program doesn't work. I have tried to plead with it and it still doesn't give work. Or by, I feel that this code is right, but I just am not sure why it won't work. Or even by, I read to my program every day and try to be a good friend, but it still doesn't like me. Whenever I try to attach to it, it gives me a core dump. I mean, to me, this kind of makes sense because, reading to your program, unlike reading to your My Little Pony plush, will probably not have much effect, considering that the program is already doing exactly what you told it to do. And actually, I kind of have to count myself lucky because I have never actually come across anybody talking like this. So the programmers I've met so far have probably not been so greatly bad. So that's cool. Okay, seriously though, should you get too attached to your program, unless you're a debugger, it's probably not that good of an idea. But, thus being said that your program doesn't work mean that you're a bad programmer? I really don't think so. Okay, with the right tools, the 10 times engineer can do the work of 10 engineers because they are so much more efficient with their time and execution. While an average engineer might be fumbling their way through a process, a 10 timeser has already streamlined it and is 2 steps ahead. So, I mean, there's this tool that will streamline your productivity all for the low, low price of €1,000 per month. I mean, where do I sign up? I mean, usually I kind of like to have some sort of a need for a tool first. But I guess we can just skip that because, it's probably like the pizza scissors of software tooling. Like, you didn't even know it existed until you found out that you need it. Or is that the other way around? Another sign of a good programmer from a different source. So, a good programmer can complete any sequence of dialogue from Lord of the Rings, Star Wars, Red Dwarf, or Monty Python. Um, so does Gilmore Girls count? Because, or are those like the only approved shows? Is there like a list somewhere that I can check for whether there is something that matches to what I actually seen? Or and is it fine if I know all but one season because that season was made by somebody else and it's like really bad? Like, like the characters don't even like act like themselves bad. Okay, listen, I I like nerdy stuff as much as the other person, but it has to be said that stereotypes like this can prevent us from recognizing the potential and the value of people who just do not fall into a bucket like this. Like, nerding out is cool and all, gatekeeping a bit less so. Because there are many people who would never even consider programming in the first place just because misconceptions like this are so common, because they feel like being a nerd is a requirement. And it's like this club, like but instead of showing them your ID, you actually have to do like a very good Jedi mind trick impression or something. And it's a shame because while being an art is cool, let's be honest, it has no bearing on how good of a programmer you can be. And nobody should be telling you that you shall not pass. I mean, get into the club, unless you know your elven name. And I'm saying this as someone who actually owned a set of handmade elven ears in my teens, okay? So there's a reason why I don't write that down on my CV, because nobody would be interested, no other reason. Okay. Want to be a better coder? Type faster. When I see someone who has been working with computers for a decade and can surpass 100 WPN for even a short burst, I'll admit it makes me cringe a little bit. It's just lazy, as Jeff Atwood put it. So, luckily, this one is a bit less demanding on memory than the previous one. So, because basically, instead of remembering all dialogue from a show, you just need to remember this one magic constant. Though I guess knowing dialogues by heart helps out when you're like all out of things to type, but you still want to keep up a respectable WPM. Um, so listen, I don't know about you people, but I spend, I think, much more time thinking than actually typing on my average day. And the thing is that the product of the thinking is often very disproportional to the time spent thinking. Like, finding a trailing comma disproportional. So what is more important, like the ability to dismantle a problem and find a solution, or writing it down? I mean, your guess is as good as mine. So if you read the talk title, you probably guessed that this one was coming. For those lucky enough not to know what this is about, this is a Twitter thread from like a year ago where a person shared their observations about 10 times engineers. And it's a longer thread and it would probably make for a whole talk on its own. So I'm only picking a couple of things here. The first being 10 times engineers' laptop screen background color is typically black. They always change defaults. Their keyboard keys such as I, F, and X are usually worn out more than A, S, and E, email senders. So I do prefer dark mode, and I usually change the default, so I guess that's good for me. I have no idea though what makes I, F, and X more special than A, S, and E. So I guess that's like minus points. And I'm pretty sure my W, A, S, D are more worn out than anything else. But that still makes me about a 3.5 times engineer, so that's pretty good. 10 times engineers rarely look at help documentation of classes or methods. They know it in memory and can recall it from memory. They write code at the same ease as writing English. No breaks, no pause, just type. Okay, so I have to be honest with you, I'm failing this one so hard. Like, there probably isn't a day where I wouldn't need to look something up, either in Python docs or in the docs of some library that I'm using. Like, I can never remember the order of parameters that goes into reduce. Like, I guess my memory is just too average for me to meet the standard of some random person on the internet. Okay, let's turn the leaf. In case you started programming in your 20s or even later, and you're wondering how to become a great programmer, the internet offers this great piece of advice. You should have started being interested in engineering when you were in your early teens. Now it's too late, all you can be is a normal engineer, as opposed to a great engineer. So I guess it's not really about willingness to learn like I thought. I mean, that's too bad. Okay, listen, I started in my teens, but the most I learned came when I actually moved from like individual projects to actually working with people and, looking at their code, them looking at my code, that sort of thing. So it's not really about the pure time spent coding, and you're really not missing out if you started later. So don't get discouraged by random people on the internet. One guy, he just graduated and called himself a programmer. I asked him a couple of questions. Have you set up the tooltips of the application? Have you made a setup for your program? Have you set up tab stops according to the flow? His answers were simple no, no, no. Um, yeah, I don't know either. Let's just move on. This I think is my favorite. So, I've written 1 million lines of code in under 6 months, resulting in a very functional, relatively bug-free commercial product on the scale of something like Microsoft Office, though totally unrelated. Further, the product was innovative and in fresh territory, as in no competitive products, no answers on Google, just completely on my own. I wouldn't do it again because I was then on the hook to maintain 1 million lines of code, but I guarantee you that is at least 10 times a normal engineer. That's about 6K LOC a day. The average engineer I've worked with puts out about 500 LOC a day. The best, but not rock stars, put out about 2K LOC a day. So it's not a clear 10 times mapping, but it's 12 times a normal engineer and 3 times a great engineer. Screw with the numbers all you want, but there's still a clear divide between rockstar output and non rockstar output. So this person kind of likes numbers, huh? When I made the joke about being a 3.5 times engineer earlier, I was kidding, but apparently there are people who are actually capable of like precisely quantifying the output of a normal engineer, presumably down to the decimal point. And they measure how good of a programmer they are by lines of code written. But you know what the best, like most maintainable, most bug-free code is, right? Like code that was never written in the first place. Like it's the easiest thing in the world to just produce code just for the sake of producing code. And bonus points if you're doing it consistently at 100 WPM or faster. But you know what's harder? Maintaining code, right? And what do you do more often? Like write a shiny new thing or maintain an existing spaghetti code base? So does it make more sense to maximize the amount of code written or its maintainability? And funnily enough, the author even kind of realizes this, but yeah, so close and yet so far. And just as a side note, optimizing for the least amount of code might also not be the best strategy ever unless you're code golfing. Okay, so the thing about a lot of this kind of advice is basically that the author assumes that everyone works exactly like them. That, unless you watch the same shows or you have a certificate on your desk stating just how fast you can type, you can only be mediocre at best. And you can even get so detached from reality that your advice doesn't even make sense to anyone but you, like the tooltips person. But this is kind of funny. But like the first thing is that actually perpetuating this myth of a rock star or ninja or 10 times or real engineer can be harmful because it can very easily alienate people who feel like they don't fit the stereotype. And you got to give it to the stereotype. It's a very smart way to perpetuate itself. And I also want to say that it has also often been used as an excuse to keep people around, basically, who keep others feel unwelcome without realizing how much of an effect this has on the community as a whole and that it actually prevents others from contributing. Like, that is the hidden price of worshipping rockstar engineers with poor manners. You might be keeping this one person who can get away with anything because they can get things done, but at the cost of losing many others. Okay, so that was a bit too serious for this talk. So let's talk about something else, okay? Let's talk about food. For example, balsamic sauce, or BS for short. I think that we as developers come in contact with balsamic sauce or BS every day. And in my opinion, being able to tell whether something is legitimate or balsamic sauce is an essential skill, basically. But unfortunately, it kind of takes time to build it up. Um, Although there is a handful of signs or red flags that can be identified regardless of experience. So imagine that we have an axis like this. Like we have like a potentially harmless and valuable advice on the left hand side, all the way to strong balsamic sauce out to the right. Let's start with a very easy one. So, if an article suggests you wire up your dusty time machine and travel back to your teens so that you can start coding earlier, I think you should feel free to disregard this advice as it will not be very helpful or encouraging. There is a big group of articles that assume that if you don't meet some arbitrary standard set by the author, you're just doing it wrong. And in some cases, this might be legitimate, like, okay, don't store plain text passwords. But the key here is the word arbitrary. So, is enough reasoning given that supports the 100 WPM limit, or is that just the magic number the author thought of in the shower? You know, your guess is as good as mine. Sometimes an article is just trying to sell you the one true solution to a problem you didn't know you had. So exercise caution. Even when they're not even trying to hide it. And finally, if an article tells you to dance around the campfire naked on the sixth full moon of a year, we know where to put this one on the axis, okay? But still make sure to apply additional balsamic filters. I mean, it sounds reasonable, but who knows what they're suggesting later on. That brings me to the last part. So, I haven't really thought this through very well because I've been making fun of random advice from the internet, so you might, you know, rightly be like, okay, everybody can criticize, right? But what do you propose? But then if I give you any sort of advice, then I'm just another random person on the internet with an opinion. So why should you take any advice from me? Well, you shouldn't, at least not until you apply your own balsamic filters to it beforehand. That being said, um, if you want to become better at writing code, I don't really have any glamorous piece of advice for you. You just need to practice. Like write, rewrite, read code, have people read your code. Write down things that take long to figure out. Make a repo, for example, with notes that you can get back to later because you will forget the solution that took you 3 days to come up with. And don't be too hard on yourself. Like, if you can't stop comparing yourself to others, remember that for every amazing programmer you see, what you actually don't see is the days of struggling and mistakes. You only see the end product. And you can be like that too. You just have to get through the suffering first. But there's one more thing, and that is that when I think of a great engineer, it's actually not that much about the code. I mean, that matters too, of course. But it's more about the attitude. It's about how the person approaches problems and how they approach other people. Like, are they willing to help? Can you bounce your ideas off of them? Can they say no to ridiculous demands and shield others from them? That sort of thing. And there is one thing that I think gets underestimated sometimes, and that is that whenever we write code, with very few exceptions, we are part of a community, be it an, I don't know, open source project or a workplace. And regardless of your standing within the community, although the higher up you are, formally or informally, the more of an effect you have, you influence what is considered normal within the community. Like, for instance, that one time you were lazy and put some spaghetti code into the code base, but it might continue to grow because other people will be like, okay, why should I care if this other person doesn't? Or, there's already hacks in there, so it doesn't matter if this new feature is a hack too. And this extends to social interaction too, because your actions set a precedent. So I guess what I'm saying is it's good to be aware of the influence you have on other people. Because, in the end, the easiest way to get a 10 times engineer is simply to have 10 completely average engineers who work very well together and help each other out. At the end of the day, it's very much okay to be an okay engineer. And if you took absolutely nothing from this talk and you just want to know how much of an engineer you really are, just to put a number on it, you are very welcome to just go pip install this package, engineer quiz, and bonus points if you can get to the true ending. So that's it from me. Thank you very much.
Thank you, Ivana, for the super insightful and entertaining talk. So let's hear it for Ivana. So as I said at the beginning, or as I made a mistake in the beginning, the questions for Ivana's talk will be taken offline. So please check out our event page after after the meetup, and you will have details on how to ask questions over there. And now I would like to yeah, sorry. Now we'll have a 10-minute break, and we will be back at in 10 minutes. Yeah, we'll be back in 10 minutes. See you then. Hi everyone, welcome back. I'm super glad to introduce our second speaker tonight. We'll be hearing about sets and frozen sets from Mridu Bhatnagar. And take it away, Mridu.
Yeah. Uh, Hello, everyone. I am Ridu Bhatnagar, and in today's session, I'll be talking about sets and frozen sets. So I'll just share my screen. Okay. Yeah. Is my screen visible? Cool. Uh, yeah. So I'll be talking about sets and frozen sets. Yeah. And I am basically from India, and uh, so here are the learning objectives for the talk. Like after the session ends, you will be able to get a grasp on the following concepts. So if you already know the concepts, so this might be the brush up for those concepts. If you don't know those concepts, so this might be a good way to learn those out. So we'll be covering up the concepts like what is meant by immutable, mutable, iterable. These are certain terms that are most commonly used in Python and also in the job interviews. Then we'll be going over with introduction to sets. Then what is the difference between sets and the other data structures? Then how do you define sets? Then we'll be dealing with operators and methods that are associated to sets. Then how do you modify a given set? And similarly, then what are frozen sets? Why do we need frozen sets? And based on our whatever we had discussed so far, in the end we'll be concluding with what is the difference between frozen sets and sets, and why do we need frozen sets. So moving ahead, these are the frequently used terms, as I had said: mutable objects, immutable objects, and iterable objects. So in Python, as we know, that everything is an object, which means that everything has its own attributes and method associated with it. By everything, I mean that every data type. Suppose string has some of its own method, list has some of its own method, likewise tuple has its own methods. So every object has an attribute or a method associated with it. Now, what is meant by mutable objects? So mutable means changeable. By changeable, we mean that there are certain methods associated with the object using which we can modify the object, and even after modification, the memory address of the object remains same. No new object gets created, we keep on modifying the same object. So that is what is meant by a mutable object. An example of mutable object can be your list and dictionaries. Likewise, so I'm giving out of many examples, I'll be giving a couple of examples. So like for mutable, we have list and dictionaries as mutable. For immutable, you have tuples. Tuples are immutable in nature. And iterable objects. Now, what is meant by an iterable object? Iterable object is like you have an object and then you can iterate over that object. An example of an iterable object would be dictionary, tuple, lists. And you might also have observed while programming, if you would have tried to iterate an integer, you would have got an error while doing the same. So integer is not an iterable object. Boolean is not an iterable object. While list, dictionaries, tuples are iterable objects. Now, moving ahead, these three concepts are something that you need to keep in mind so that you don't get confused when I interchangeably end up using these terms. So, introduction to sets. What exactly are sets? So, set can be imagined as a collection that has unique elements present inside of it. And in the first code snippet that you see, here is one of the ways that you can define the set. All the elements in the set are unique, and we are defining a set using the curly braces. Another thing to be remembered is set in nature is mutable. Set as a whole is mutable in nature, but each of the elements present inside of the set must be an immutable element. You cannot put a mutable element inside of a set. So these are certain things that need to be remembered. Another way of defining a set is you write set and then you have parentheses, and inside of the parentheses you have an iterable or iterable, whatever you call it. So I do set, then we have a method. Then inside of it, if we can pass a list, we can pass a tuple, we can pass even a dictionary, and then the output that we'll be getting is again a set. And the output of this set would be a set having the curly braces. So these are some of the ways for defining a set. Now, how you will get a set from a list? So we'll be going quickly over this. I have a list, and you can see that as list can contain even duplicate elements. So my list is having a duplicate element, that is 12. But when I do a set of this, so I'm getting all unique elements. Likewise, you see here there is tuple, and then tuple has a duplicate element 5. But when you do X, then again you are getting a set of unique elements. Now, every method that you have, like all the methods like finding the length of a set, or finding a length of a set, or using set comprehension, all these are possible with sets. Like these are the things that we even do with dictionaries and lists. So those things are possible with set. You can write a set comprehension, you can iterate a set, you can also check whether a particular element is present in the set or not, and for that you will have to use a in operator. For that I don't really have a slide at the moment. So from that, moving ahead, we are discussing now that how to create a set from a dictionary. So we have initialized a set, and as dictionary is also an iterable, I am passing a dictionary inside of the parenthesis. And now when you again type X on your interpreter, you will see that it returns you only the keys of the dictionary. So also remember that the difference between a set and one of the differences between the dictionary and set is that dictionary has key value pairs, while your set doesn't have key value pairs. Set is only going to have the keys. However, both of them use parentheses, so you don't have to get confused with it. So these were some of the basics about sets. Now moving ahead, we will be covering up that what are operators and methods present in sets. So as the Venn diagram that you can see, this is a relatable Venn diagram. Like in mathematics, when you do set and set theory, that is also the time that we come across Venn diagram. And somehow as a result of this, whenever the term set comes to my mind, all that I can imagine is these Venn diagrams. So starting with the one of the Venn diagrams that we have in front of us is that of union. So there are two ways of doing union in Python. Either you can use the union method, or you can use this bar operator that is present here. Union means this tells us that what all elements are present in set A and what are the elements that are present in set B. So the element should be either part of set A, or it should be either part of set B. So here I'll just tell a short story out that now that everyone, we all are home and everyone is starting out their own newsletters. So imagine that you are the owner of two newsletters. You run two newsletters. One of the newsletter is technology newsletter because you are passionate about what is happening on technology front. And now that everyone is talking about the creator economy and passion economy, so you are also interested in passion economy, like you have been researching on that. So that you run two newsletters. Now a day comes, all these are paid newsletters, right? There is some investment of time, so there should be some return to it as well. So now your agenda is that you want to see who all are your customers who have subscribed to both the newsletters, who are the ones who have not who have subscribed to only one of the newsletters. So in such a real world use case, we use sets. So imagine these numbers to be the customer IDs. Each customer is having a unique ID, or it can either be ID or a unique username also. So here for the sake of example, I am considering IDs. Now what union is going to do is, if you are, so all I wanted to do was, I wanted to know that who have subscribed to both of my technology and passion economy newsletter. So the easiest way out was to just do technology newsletter dot union passion economy newsletter. Now, the resultant of this would be all the unique customers that have either subscribed to my technology newsletter, or they have either subscribed to the passion economy newsletter. So, you can yourself try out and see what is the output, or I can also just tell that it would be 101, 102, 103, 300, 400, 500, 600, and 700. Okay, so this is going to be the output to check that either they have subscribed to technology or they have subscribed to passion. Now I found the number to be really good, and I was curious that okay, if people are people are loving one of my newsletters, now let us check the number of people who are loving both of my newsletters. Uh, oh sorry, I skipped this slide. So this is another way of doing the union itself. So earlier we had used union method. Now here we have used union operator. The purpose is one and the same. So this is only these are the two ways of finding out the union. However, when you are using the union operator, one thing that needs to be kept in mind is that both of the like technology newsletter and passion economy newsletter, the data type needs to be set only. However, while you are using union method, the data type of passion economy newsletter can be anything. It is not necessary that it needs to be a set. Here you can pass any iterable, but when you are using an operator, you need to be specifically using both. On both the sides there should be set, otherwise there would be an error. And next, out of curiosity, I wanted to check that how many people are there who have subscribed to both of my newsletters. Now, one way of doing so, there are two ways of finding that. Either I can use the intersection built-in method, or I can use the AND operator. So now we have same list of customer IDs with us, and for finding the common, all I need to do is do an intersection. And now, as you can find out yourselves, that 102, 103, and 500. These are the three customers who have subscribed to both of my newsletters. And now another way of finding this same output is you can use the AND operator and find out the result. Moving ahead, another method is the difference operator. Now difference is going to tell us that how many people are only present, have only subscribed to one of my newsletters. So for finding this thing, we can use either the difference method or the minus operator. Also, these Venn diagrams are good to create the mental models regarding what each and every method is going to do, unless provided that they don't confuse you. So now all we need to do is find the number of folks who have subscribed to only one newsletter. So one way of doing it, I was interested in finding out people who have subscribed to the passion economy newsletter. So I wanted to remove basically everyone who had subscribed to the technology newsletter. So the result I had got was 600 and 700, because 600 and 700 were the two people who have subscribed to my passion economy newsletter and have not subscribed to my technology newsletter. That was all I intended to find out. And if other way around, if you wanted to check out who are the ones who have subscribed to your technology newsletter and not the passion economy newsletter. So you would have to switch it up. So here, instead of passion economy, I'll have to replace it with technology newsletter, and instead of technology newsletter here, I should have replaced it with passion economy newsletter. So based on the use case, you need to figure out that which condition needs to be put. Another way of doing it using the operator is you can directly use the minus operator. Now, what is meant by symmetric difference? So there are two ways of again finding symmetric difference. One is by using the symmetric difference method, and other is by using this operator that you see here. And here, as we were doing ahead, here is again the Venn diagram. So now the Venn diagram says that x1 is one set and x2 is another set. X1 set is having two elements that are foo and bar, while x2 is having two elements. I don't know the pronunciation. It is a random name. Okay, so QUX and QUUX. So it has two elements, and also one of the common element is present that is named as baz. Now, what the symmetric difference will do is, let us see. So now again we have our two newsletters. One is passion economy newsletter and another is technology newsletter. So now this lists everything. Okay, so this basically what it is doing is it will return you all the customer IDs that are present except for the ones that are present in common. So it will remove the customer ID that is common, that has subscribed to both the newsletters. That is what symmetric difference is doing. So you, in the result, when you see you have 101 because 101 has subscribed to technology newsletter. Then you have 600, 600 is subscribed to passion economy newsletter. Then you have 300, 300 is again technology newsletter. Then you have 700, which is passion, and then you have 400, which is technology. Now, as you can see, 103 was the customer ID who had subscribed to both of your newsletters. So that did not come in the result. So using symmetric difference is a way to find out those customers who have only subscribed to one of your newsletter. And then another way to find it out is using the operator that you see here. The result is going to be the same. Now, what is meant by disjoint? Disjoint is basically another method that is present in set, which tells us whether a set is disjoint of another set or not. So I have technology newsletter and then I have passion economy newsletter. Now I want to check whether one is a disjoint of another or not. So you have 102, 103, 500, 600 and 700. Now we check that whether all these elements are present in the technology newsletter or not. So as all the elements are not present, so the result is false. So it just returns a Boolean value and tells you whether one is the disjoint of other or not. Likewise, like these are the methods which would give you only the Boolean result. They would not return like any of the sets or anything. It just tells you whether the given condition is true or not. Subset method is the one that tells you whether one is the subset of another or not. So whether passion is the subset of technology newsletter or not. So here again you will have to check whether all the customer IDs present in passion economy newsletter are present in your technology newsletter or not. And then it will tell you whether one is the subset of another or not. Another way of finding it is using the operator. And here this one is greater than and equal to sign. Don't get confused by this. It is because of the tool I was using for writing the code snippet, but it is greater than and equal to operator. Now, other methods that are present for modifying a set are add method, update, remove, discard, pop, and clear. So these are easier methods only. If you are, so suppose one more person subscribed to your newsletter and you wanted to add that customer ID to your set. So you can just use the add built-in method and add that customer ID to your set. Likewise, if you have to update something, so if there are 3-4 people who are your new subscribers, and again you wanted to update your initial set, so all you can do is you need to use an update method, and then inside of a list you can pass 200 and 900 the new customer IDs, and then this would be the output of your resulting set. What needs to be remembered is the difference between add method and update method. So when you have to add more than one element, you can directly use update, and if you have to add only one element, you can use the add method. Remove. So remove removes a specified element from the set. All I wanted to do was remove customer 700 from the Passion Economy newsletter. So I just put customer ID 700 and remove the person. Likewise, discard. So remove and discard are doing one and the same thing. Whenever you pass a specified element to it, they just remove that given element. What pop does is pop will remove a random element from the set. So the difference between discard, remove, and pop is that inside of pop you don't pass any specified element; it just removes an arbitrary element. What clear does is it just empties the set. So if your set is having multiple elements and you want to just empty the set, you can directly use the clear method. So now this was all that we had. These were the main concepts for sets. Sets has various methods for modifying it. It has various operators and methods associated with it. And more now, these are all the theoretical aspects of it that we learn. Now, the use case that I was trying to explain was one of the real world use cases where you can apply your sets knowledge and figure out what is happening. Also, sets as a concept, more than practical application of sets is one of those concepts that also comes, you might come across it while solving competitive programming problems or anything of that sort if you do, or while the interviews. And sets are also used in cases where the problem statement says that remove the duplicate elements from the list. So now for removing the duplicate elements from the list, all you can directly do is just convert that list to a set and those duplicate elements would get removed. And another way of doing it was through loops and everything, but using sets, those things can be done pretty quickly. Now, next we move on to frozen sets. What are frozen sets and how are they different from sets? So sets, as we had discussed, that sets are mutable in nature. Frozen sets are opposite of that. Frozen sets are immutable in nature. Now, as we had already discussed in the beginning about immutable objects, so that is the reason why frozen sets don't have the methods like add, remove, pop, discard. Those methods are not present in frozen sets. However, frozen sets are useful because you can use these as an immutable object. Now, if we relate the concepts, we know that keys in dictionary are immutable. Mutable objects are not cannot be present as dictionary keys. So it is here where frozen sets help. Suppose you want a condition where you have a complex dictionary key and you want an immutable object to be placed as a dictionary key. So their sets cannot be put up and frozen set can be used as a key. And here is an example of initializing frozen set. So I have f is equal to frozen set and I have initialized it like this. So the output that you see is going to be like this after initialization. So the only important thing that needs to be remembered is mutability and immutability here. And then now here the competitive advantage of the frozen set. Frozen set, so I have two frozen sets, 1, 2, 3, another one is ABC. And then you have D is equal to your dictionary. X being the key and this foo being the value, Y being the key and bar being the value. Now when you again see your dictionary, you have frozen set as the dictionary key. And now, if you have been following along till here without getting bored and thinking, Vidhu, all of this is fine, but why have you been explaining us a lot of theoretical concepts? So the thing is that, as I had told you earlier, this is one of the topic that is good to know topic, because knowing about data structures help us in times when we need to store data in memory. So it is this time where all of this knowing such concepts basically help us. And in real life application, one of the use cases that I was discussing all throughout the example was a real life example. Another example is when you go onto any e-commerce platform or e-commerce platform and you are searching for, suppose, books. Now while you are searching for books, you are applying various filters on the website. Filters like I need a book between so and so range. So you have specified two specific ranges, or you are searching for a book that is a physical copy and present between X and Y range of money. So there we are applying various filters. So that is one of the places where sets are used. Another application is databases. So when we have database tables and we are doing joins, we are applying joins on multiple tables. There also there is application of sets, and if you just observe the two Venn diagrams, you might find some similarity between the Venn diagrams and each of these methods. So these are the places where you will apply sets, and that is why sets is another data structure that is less talked about but good to know, and it is built in Python. And that was all I had for today. And thank you so much for like for the talk, for being there for the talk.
Thanks so much, Mridu, for the super interesting deep dive into sets and frozen sets. Let's hear a round of applause for Mridu. Okay, so if anyone has any questions for this second talk, feel free to ask your questions on Slido. You'll find the link on.
Oh yeah.
You'll find the link on the Meetup page, or I will just share it.
Now is it fine?
On the Twitch chat.
Okay.
Yeah, there are several comments saying that they learned some new stuff from your talk. I think someone said, "Cool, I didn't know that." When you talked about union, I assume they referred to the pipe operator for union. And someone else says, "Thanks. I was playing around with sets today, and you clarified a couple of things." So far, no questions. Okay, then I will give it away to my colleague Ellen for the closing session.
Yes, let me share my screen. No. So, thanks everyone for coming. It was really great to have you here. And thanks especially to our speakers today from Ivana and Miguel. And our next meetup is in a little over a month on a Monday on October 27th. And we're looking for organizers. As you might remember, Miguel just left us. And so we're always happy to have more people that want to help us organize great meetups. And we're, of course, also looking for speakers. So if you have an idea for a talk you want to give, or if you want to hear about something, please go to this link or the QR code. We're always really happy if you have something cool to share, or if is there something that you really want to hear about, then just let us know. And of course, we also love if you tweet about us. So you can follow us on Twitter at PyBerlin Python, or you can join our community Slack channel at this link. And thanks again for coming. We've now reached the end of our meetup. Great to have you here.